Surface area and volume, it's always everyone's least favorite. And I'll tell you this, it's only because it takes a long time to do. So it is not that difficult, but I want you to be patient and watch step by step by step to kind of break it down and realize what am I trying to figure out, and it will make a lot more sense as you go through. So let's start with the volume. Volume has a general formula of the area of the base times the height of the shape. So if I'm looking at this triangular prism, the base is actually the triangle. Okay, it doesn't make a lot of sense, but think about any shape can be turned on different ends, right? So you can't just say the base is always the bottom. That's not going to work out. Now, in this case, we could turn it and we could make the triangle be on the bottom, right? If we wanted our base to be on the bottom. But we need to look at it as a prism is always named by its base. So this prism is called a triangular prism because it's made out of a triangle that kind of got stretched out. So I'm going to find the area of that base. Now think about this. I'm finding how big this is, and then I'm going to find out how far up it goes. So think about this as like layer upon layer upon layer of triangles. And when you do that, it will help. Now, I kind of misdrew this because I see it's 3 meters, but let me redraw that really quickly. So what we're talking about is this original base, right? I still kind of drew it wrong. Being multiplied 3 times. We're talking about 3 chunks here, right? 1, 2, 3, because we're talking about this being a meter by a meter by a meter, a meter by a meter by a meter, and so on. Okay, so that is why we're taking the area of the base times this other distance. We're going to call that one the height. Now, again, it probably makes no sense that we're calling this direction a height, but maybe we just need to take our brain and shift it and say, okay, if my shape was actually sitting on its base, then this would be the height, right? So basically, I'm going to find the area of the base shape, the shape it's named by. So I'm going to find the area of this triangle. To find the area of a triangle, this will be on the wall still during your test. I'm going to take 1/2 times the base of the triangle times the height of the triangle. So 1/2 times the base of the triangle is 2, and the height of the triangle is also 2 in this case. So 1/2 times 2 times 2. 1/2 times 2 times 2 is actually 2. Okay, and that is how many squares make up this triangle right here. And then we're saying, well, what if those squares were actually not just squares, but they were actually cubes? Okay, and then we're going to take those cubes and we're going to say how many cubes would be in this whole entire thing. And so that's why we're taking this and we're saying, okay, what if they weren't just two-dimensional, but they went back this far, right? So we've got our awkward cubes going back this far, and you have another layer of them and another layer of them. So if this layer was 2 cubes, now instead of squares, it's 2 cubes, and this one was 2 cubes, and this one was 2 cubes, then you could say, oh yeah, the volume or the amount of cubes that would fit inside of here would be 6, right? So here I have the area of my base, and I'm going to multiply it times the height, which we are calling 3. And that's how we get 6 meters cubed, because now we're talking about cubes. Let's do a different shape. You've known how to find the volume of a rectangular prism for a really long time, but you've known it as length times width times height. That is what we're doing. We're taking the length times width times height, but think about it this way. We've got this layer again on the bottom, right? We're gonna look at this as the bottom. Now on a rectangular prism, you could really stretch it anyway because all of the sides are rectangles, so it doesn't actually matter which one we're calling the base. So I'm going to call the actual bottom of this shape the base. And we're going to say, okay, there's a layer down here, and this layer is made up of 5 going this way and 7 going this way. Oops, 1, 2, 3, 4, 5, 6, 7. Okay. And when I multiply that out to make it what it would look like if it, oh man, my picture's terrible, but what it would look like if it went all the way into cubes, I'm taking this 7 times the 5, right? That's why I'm finding the area of the base. Big B means area of the base, 5 times 7, and that gives me 35. And then again, I'm looking at this as layers. I'm saying, okay, so we've got this layer in the bottom, right? And then we've got another layer and another layer and another layer. How many? We have 9 layers of those. So I'm going to times it by those 9 layers. And I'm going to take my 35 times my 9, and I get 315. And that's how many cubes would be inside of here. So I'm going to call them meters cubed. Meters cubed just means that my cube is 1 meter by 1 meter by 1 meter. That's how big this cube is. So this is actually a pretty big box. All right, moving on. The big one for 7th grade is finding the the volume of a cylinder. To find the volume of the cylinder, again, I'm finding the area of the circle, which would be the shape that got stretched, right? And I'm going to multiply it times the height. So again, I'm finding the area of the base times the height. The area of a circle is pi r squared, and then I'm going to times it by this 9 for the height. Okay, so pi r squared, well, I have a radius of 6, so pi times 6 squared times 9, and I'm just going to plug that all in together, except I'm going to use 3.14 for pi because then it won't give me quite as long of a digit of answers. So I got 1,017.36, and I'm going to call that feet cubed. Volume is always going to be cubed. Let's do another cylinder. Okay, so for this cylinder, again, it gave me the radius, so I want to find the area of the base times the height. So I'm going to take pi r squared times the height. Pi, 3.14, times the radius squared times the height. Okay, so 3.14 times the radius squared times the height is 2,826. Exactly. And that's feet cubed. Okay? Let's move on to surface area. So the surface area, we're going to only find surface area of cylinders. And so surface area, I like to think about all of the parts. So what surface area is it's the area of each one of the surfaces that make up the shape. This is a lot easier to think about when we had, let's say, a cube, okay? I think of a dice when I think of this cube, and I think, okay, this has 6 sides, right? And every single side is the same size on a cube, or on a dice. And so if I found the area of one of these, all I would say is, well, there's 6 of them, so I could take that area and times it by 6, and that's going to be the area of all of those surfaces, right? Put together. It's not quite as simple when we think about a cylinder. So a cylinder has a top, and that top is a circle, right? And a cylinder has a bottom that's kind of hiding down here, and that's also a circle. But this shape that goes around it is so tricky. So think about if this were a soup can. And on a soup can, if you've ever played around with a soup can and you've pulled the label off of that can, you'll notice that the label is like a long rectangle that just wraps its way all the way around the can. So this is really like taking this thing and it's going all the way around, right? The can. And so when we unroll it, it's going to be a rectangle. But when it's rolled up, this rectangle's top distance here is the same distance as it would take to go all the way around the can. And all the way around the can is a circumference. So what I'm going to do is I'm going to find the area of my circle. And since it's the same on the top as the bottom, I'm just going to have it go twice. And then I'm going to find the circumference of my circle. Ooh. Okay, and I'm going to use that as this distance because I want to find the area. And in order to find the area of a rectangle, I need to take the base times the height, or one side times the other side, right? Well, this side, I actually know this side is 8. So I can put that there. But I need to figure this one out. by using the circumference because we just said this one goes all the way around the circle. So let's go ahead and find the area of each of the circles. So pi r squared is area, so I'm going to take pi times the radius squared. And when I take 3.14 times 16, or 4 squared, I get 50.24. So this one here is 50.24, but without having to do it twice, I'm going to write this one's 50.24, or I could take this and times it by 2. Okay, and then I know that the diameter times pi is my circumference. If I don't know that, sing that little circle song again, and it will tell you that answer. So when I need a circumference, I just use pi d. So I'm going to take 3.14 times, since I don't have the diameter, I need to figure it out. The diameter is going to go all the way across the circle, so that's going to be 8 millimeters. So 3.14 times 8. So this distance here is 25.12. That's the circumference of the circle, also the top of this rectangle. And I'm going to multiply that times 8, and that gives me this area that's inside here. Okay, so what I did was I took the 25.12 times the 8, and I got 200.96. So then I'm going to take all of my areas, because surface area would be every surface put together. So I'm going to take 200.96 plus 50.24 plus another 50.24 for a total surface area of 301.44 millimeters squared. Area, whether it be regular area or surface area, is squared. We're measuring a flat surface. Okay, let's do another one. This one's already laid out for us. You can see the different rectangles and circles already, but I don't know this distance still. How do I find it? Remember, this would wrap all the way around this circle. So I'm going to use this circle, the measurements on that circle, to know what my circumference would be, or this distance. So remember, circumference is pi times the diameter. Since the radius is 3, the diameter is 6. So I have this distance as 18.84. Okay? And I'm going to times that by 7. And so inside this rectangle, the area is 131.88. I'm going to find the area of both my circles. Area is 3.14 times the radius squared. So I have 28.26 and 28.26. I didn't do that problem twice. I just knew that they were going to be the same. And now I'm going to add all three of these numbers up for a total of 188.4 centimeters squared. Let's do another one. Okay, this one's tall and skinny. We're going to take the two circles, 1, 2. I'm going to find the area, pi times the radius squared, pi times the radius, which would be 3 squared. And I'm going to find the area of each of those. So pi times the radius squared. Again, I have 28.26. I think we had that on the last one, 28.26. Okay. Then I have this tall rectangle. Okay. It's got 18 meters as the one side, and the circumference is going to be your other distance. So circumference is pi d. I'm going to take pi times 6. Again, I'm using 3.14 every time I say pi. 18.84. And to find the area, I'm just going to take 18.84 times 18, and that gives me 339.12. I'm going to add this area, and this area for a grand total, let's see, 28.26 and 28.26 of 395.64 meters squared. I've got 2 more examples. Let's fly through them. Actually, I lied. I think this is my last example. Okay, so for this one, again, I'm going to find the area of the circle. the area of the circle, remember they're always the same, and the area of that rectangle that goes around. So the area of the circle is pi times the radius squared. Radius would be 4 in this case. So I'm going to take 3.14 times 16, and that's 50.24. 50.24. This distance here, I hope you see that it is 10. And the circumference is pi times the diameter. So I'm going to take pi times the diameter. I get 25.12 times 10, which is 251.2. I'm going to add this plus this plus this. So let's see, 50.24 plus 50.24. I made a mistake in my typing. Just a second. 50.24. I got 351.68 inches squared. All right, I feel like I might have forgotten the very last one. Let's see. Oh no, I did them all. Okay, hopefully that was enough for you to master this test. I know that I went really, really fast. There are lots and lots of videos on these things on YouTube. If you want to watch more, just search things like surface area of a cylinder or volume of a prism. Things like that will help you a lot. Good luck on your test.